Thank you for joining the February 12th, 2019 VOLTHA call. Do keep in mind we post the recordings to YouTube, so be mindful of that during discussions and presentations. And with that, we have a few topics on our agenda today. We do have a review of the design for the Go-based Open OLT adapter. Amit had sent that out to VOLTHA to discuss a few days ago. And then we also have a number of new JIRAs to take a look at. And then time permitting, then we'll go into review of what we have in scope for 14, see if we have any adjustments to make there. And
Julie, Amit has not joined yet.
That's what I was just saying. So I think we'll go into the review for the new JIRAs. And if you can, if someone notices Amit joining, feel free to interrupt me and we'll switch over to that presentation. Let me bring up the new JIRAs, starting with 1456. Okay, so the first one here was a new defect that was opened to delete an OLT fails in version 2.0. And that one was opened by Ken. Ken, it looks like you've assigned that to yourself as well.
Yeah, that's correct. That's Stefan saw an exception somewhere, so I told him just open a bug. I'll look at it later.
Okay. So are you expecting you'll take a look at this in Sprint 14 then?
Yes, I believe so, yes.
Okay, I'll go ahead and place that in then. Thanks.
And then Ken, so this is the delete any OLT, right? But right now, of course, only the PON SIM you have.
Yeah, that's correct, yes.
But
it's really about an exception that was being produced. It's more to address that.
Okay.
Okay. Next item was another defect open 14. Oops, I'm on the wrong field. It's just showing the open ones. Okay, so 1457, this one is already complete. Adapter callback causes an exception on callback, and that one was already completed. Any quick questions from the group before we move on? Okay, next item is 1458, and this one is another bug that was opened, intermittent failure when enabling an OLT. This was opened by Stefan. We don't have an assignee for it currently.
That would either be me or Stefan, but you can assign that to me.
Okay.
So right now we don't know. Is that something the enable command didn't go down, or it just doesn't react to it?
No, actually, it does go down. It just in a cluster mode, when we have two calls handling the same request, so they compete to get the request, and there's a time limit that they can process it. So when the time expired, everyone tried to get it. So there's a competition that happen, and so there are some timeout that happens that should not happen. And so this is the bug about that. So we need to look at that.
One thing is, right now you're saying 2 cores, right? So, but the high availability, wouldn't that be 3 core? And each core has what do we mean as 2 cores?
Oh, okay. So in the high availability, what you have 3 set of pairs.
Right.
So when I say 2 cores, I mean like in one pair, those 2 cores in one pair. So you will still have 3 sets. So in total, you'll have 6 cores all running at the same time.
Right.
But the 2 of them, they are active, so they are handling the same request.
So, okay. Okay. Okay.
Other questions? All right. Next item is another defect, 1459, in multi-core environment. A core may fail to fully synchronize the data model, and this one has been completed. Any questions from the group?
The complete in the Sprint 13?
Yeah, that was in Sprint 13, yeah.
Okay.
All right, next one is the new task 1460, create and populate a Volta Protos repo, and that one has been opened by Zach and assigned to himself as well. So that I think is, we've had some offline discussion if I remember correctly.
Zach, it is on right now.
And that's done. I just need to actually create the contents of that.
Okay. So you said this one is done though?
No, it's not done. It's not
done.
done.
Done. Okay.
The create portion isn't the populate. The create portion is done. The populate is not. I should mark it as in progress.
Okay, got it. I'll do that. Okay. Thanks for that update, Zach. And
it should be done this soon, right? So it's spring 14. Wow.
Yeah, this next sprint is over in like a week and a half.
Okay.
2.5
1st of March. Okay.
Yeah.
It'll get done this sprint.
Okay.
And Julie, I saw Amit online, so I don't know if you
great.
want to...
Thank you. All right. Amit, thanks for joining. Are you on the audio?
Yes, sorry, I just joined.
Great, thank you. And we wanted to go over the proposal you put forth on Volta Discuss for the Go-based Open OLT adapter. I believe I have it up on my computer also, but I can give you presentation rights if that's easier, or if you've made any changes.
I've not made any changes. Maybe you can project the slides because I've jumped to the phone. So
sure.
Yeah.
And just let me know when you need me to change slides. Thanks, Amit.
Yeah, before we do that, has AT&T Foundry joined yet? Okay, thanks. I mean, go ahead.
Yeah. So I don't know how many people got a chance to go through the slides that I posted on Volta Discuss, but yeah, let's just walk through that. So as you would see in the slides, I put two models. One is the concurrency model, and the other is high-level module decomposition. So first, let's talk about the concurrency model. So here, the basic idea is to use the Kafka intercontainer proxy that is already developed, and use that as an entry point for reading from the Kafka bus and writing to the Kafka bus. And so we would have a main thread kind of a thing, which would subscribe to the Kafka topics, right, for the device agnostic topics, and it would wait for termination, right? And whenever a device agnostic topic comes in, it would be on a different Go routine. And for example, here it's a create device handler. It would go ahead and the box that you see in the blue color, create the device handler instance. And at the startup of that particular device handler instance, that particular device handler would go and subscribe for the topic of this particular device. And it would start a gRPC listener Go routine, which would be an infinite loop listening only on the gRPC channel. And from that point onwards, any message that comes from the northbound Kafka bus would be on a separate Go routine, and it would process that and write it down to the gRPC channel in the context of that Go routine itself. On the indications received on the southbound from the gRPC channel, it would come into the thread which is blocked on that, and depending on the request, it might spin out different Go routines to handle the gRPC event, do the processing, and post it onto the Kafka bus, or it could do it on the same thread itself if it is like a trivial kind of a thing. So yeah, so that's the high-level idea. Any questions or suggestions?
Hi, Amit. This is Ken.
Yeah, Ken.
The idea is pretty good. Just like on the diagram itself, you have the Kafka intercontainer proxy, Actually, you don't talk, other than creating devices, you don't talk directly to it. Well, you could. When you get a request coming in, the request handler that actually decode the Kafka messages into the adapter messages. So on top, between your Kafka container proxy there and the OLT device handler, you have a request handler that handles the northbound request. And another thing that I don't know where I'll mention that, but just one thing, like when you're talking about your concurrency model, so when you get a request, you go to the completion. The core requires that we get an act right away when you receive a request. For example, when you get an adopt device that comes down, the core needs an acknowledgement that you have received it. And the reason is because we have a limit in the core, because there's two cores running in parallel, and one of them is issuing that request. So there's a time limit that it's going to wait to get an act back. If it doesn't get any act back, you assume that, oh, there's a failure, and then potentially the other core may take over and start to run with that request. So when you get any request coming from northbound, unless it's a request where it's actually asking for something right away, you will need to send an act back to the core, and then after that spawn the thread, in this case the go routine, to execute the command.
Okay. Yeah.
So Ken,
that's good.
Ken, a question.
Yes.
So in most cases, an act back just means that an adapter received the message. It doesn't mean that it succeeded.
Yeah, that's correct. Yes.
Then, I mean, how would the core handle a failure if a message, the adapter failed to process the message and it wants to report back? Is there a mechanism?
So there is a mechanism to send this stuff back. Currently, for example, like anytime you create a port, for example, you'll send a port created message. In terms of error message per se, we don't have an RPC that has been created just to for error messages per se. Maybe we need to have one for like.
No, for example, the specific case of adopt device comes down. What you're saying is that the adapter needs to immediately respond back that with an ACK.
That's correct.
And then if the adopt device, could take whenever let's say the OLT is not there, and the adapter keeps retrying, and eventually times out and now wants to report back to the core, or does the core even care about that? Saying that I tried and I couldn't connect to I couldn't adopt this device. So
So yeah. So the way it works, it's just from a high level perspective. So you get the core itself receive an enable device from that device. So it takes that and change the state of that device to be activating, and send that request to the adapter. The adapter sends back an act, and the act just release resources in the core, and that's it. In the core, the state of that device is activating, and that's it. It will wait for the appropriate messages from the adapters. For example, the adapter will come and says, "Oh, I want to update the device. Here's a certain status about it. I have some ports that has been created. I've discovered some PON ports or some UNI ports, whatever." It will send that back up, and in the core, when it's get enough of those state changes, that's when the core will create the logical devices. So, and if there's some errors, stuff like that, the state of that device will still remain activating in the core. Do you see what I mean?
So when does the core cleanups?
By itself, the core doesn't clean up. So it will require a message, for example, a delete device or something like that coming from the northbound to delete it. because we don't know when we need to clean up. So if we want to have an automatic cleanup in the core, then we'll need a message from the adapter to say, sorry, this device, we won't be able to enable it. Then we'll need a separate message for that.
Yeah, okay. I think not to hold up this thing. Yeah, basically something northbound provisioned this OLT, and you want to notify like a trap or something to the northbound that it failed. And does that need to go through the core? And do we have messaging for that? So we can take this offline.
Yeah, but it would be good to have. It's a good question. It would be good to have an error back message. Like it could be a generic one, or we can make it specific for those kind of messages. And like you say, those things takes time. It doesn't mean like it would take like right away a minute, a second, or it could take like a few minutes before we get the full status of an OLT or an ONU for them to be activated.
Right. Thanks.
And on that same topic, right? So if the activation or any kind of response coming back, it will also go all the way up to the CBA level, right? Is that correct?
To the CBA level, basically like once the OLT, well, in this case, OLT, it could be any adapters. The moment the adapters send all those messages back that are enough for the core to create a logical device and the logical ports and everything, the moment the logical device is available, then the owners and above, they will be notified that there is a logical device on that system.
Right. Okay.
But until we don't get any of those, then there's no logical devices.
Right, but let's just take a request from an external map system. So if I have a request that comes to admin down and ONU, for instance, right? So the first ACK that comes back from the adapter is an ACK to the core that says, okay, I'm taking care of that request, right?
Mm-hmm.
But there may be a transaction ID associated with the original admin down of the ONU that needs to get a response, right? So once the adapter has completed the admin down of the ONU operation, a response presumably would then go back from the adapter saying, yeah, I've done it and it's successful. So what is that? Where does that acknowledgement go back to the source of the originator of the request?
If you're putting like an ONU down, basically what it means is the port on that logical device would be gone, representing that ONU, right?
But sure, but we're implying a result from these notifications, right? There's no actual response to the request, or is that generated somehow?
I don't follow. Like if we want to have a response, the request right away, so we are making everything synchronous, right?
Well, no. The response should come when the hardware has implemented the request, right?
Mm-hmm.
Or it's been the hardware's not there, then you stored the request somehow.
Mm-hmm. And in what form of what kind of messages do you expect that request to come back?
So if I have, let's say from the CLI, I say admin down so it's you, right? Is the CLI going to get a response saying yes, that was successful, or no, that failed?
No, the CLI will have to query the core for the latest status. There's no notification back in that sense.
So yeah, so let's move on. I think we can. This is a topic we can basically we can take up afterwards as offline. Amit.
Yeah. Yeah. So if no other questions on this slide, maybe we can move on to the next one.
next page.
Yeah.
Now.
So here we've tried to just try to list the pros and cons of this. So one of the points that we are trying to, or a design guideline that we're trying to follow here is that we will try not to store any local state in the adapter. And if at all during implementation we figure out that we need to store a state for some corner cases, it would be persisted in the KV store. And because we have multiple Go routines working in parallel, right? So any such state stored would be either protected using locks, or access to that would be serialized. So that's a design guideline that we would follow. So some of the pros are that multiple operations on a OLT can happen in parallel, as well as operations on multiple OLTs. If one Docker instance is handling multiple OLTs, can happen in parallel. One of the cons out here is that because we are using Kafka messages and basically using Kafka and spawning multiple Go routines, so we might have to deal with the head of line blocking for the commits to the Kafka bus, right? Excuse me.
What do you mean by that?
So basically, say I get request 1, 2, 3 from the northbound, right? And I need to commit to the bus, right? Saying that, yeah, I don't want to read it the next time I come up. So, but unless I have actually processed the complete message, I cannot commit it. And now say that the request 1 takes more time, say it takes, just hypothetically, 2 minutes to complete, but request 2 and 3, they get done in 30 seconds. But I cannot commit 2 and 3 because I have not yet processed request 1, right? So
why would you wait for 2 minutes to process a request? The way it is currently, it's and you can see it in the code of the intercontainer messages. When a request comes in, it read the request and sends it out to a Go routine, and then immediately says, I read it.
No, so for example, if I take the case of, say, enable the OLT, right? So enable the OLT might take quite some time. But along with that, in parallel, if I get more requests from the northbound, and that might be for another OLT, where say we are trying to add some flows, the flow addition might happen much quicker. But this enabling of this one OLT is maybe taking 2 minutes. Just hypothetically, I'm throwing up sometimes. But I cannot acknowledge.
Okay.
Yeah, I cannot acknowledge the flow addition request because commit the flow addition request because I have not yet committed this.
No, it's if you have 2 different OLT devices, you're going to have 2 different topics. So you're committing different topics.
Yeah, so maybe that's not a good example, sorry. Yeah, but even on the same device, right, some requests might take more time than the other. That's what we're trying to bring out. So if that happens, then in that case, some of the commits would be waiting.
Yeah, that should be quite true. That shouldn't be the norm. But on the other hand, in a sense, you want things to be sequential for a given device. You don't want to get, like, for example, enable and delete at the same time and try to process both of those requests at the same time, right?
Ken,
yes, go ahead.
Yeah, it could be a possibility where the first request is actually going to the device and doing something, and the second request is just maybe fetching something from the KV store and returning back. I can see that where the first one is 2 different kind of requests coming in, one to the device and one just like a read operation that it can be satisfied from some state in the config store. So then you would have you needn't maintain sequentiality in these 2 cases. You could send the first request to the OLT and then in parallel, while you're waiting for it, service the second one?
Yes, that's correct. But I don't see how would you have a not be able to submit that you have read that request. So I'm kind of stuck on that head of line blocking for that case, even for
but
that.
I thought all the reads go through a separate path to the KV store, right? I mean, only things that go to the adapter, like doing a set operation or some action, it would go directly to the adapter. I thought there was a separate read path that went around to the KV store directly.
Well, the core doesn't go to the KV store of the adapter. We will have to invoke an API on the adapter for the adapter to go to the KV store if it needs to read it from the KV store.
Okay, so Ken, let's look at the other cons first, and then maybe we come to this one again. So, yeah, so what we're saying out there is, so if the adapter has a dependency on something which is outside of the adapter, right, and it has to, again, and use Kafka-based messaging to get that dependency resolved. So, for example, if it has to get something from the core before it can process this particular request, in that case, it has to be a blocking call, and somehow we have to be able to use channels to pass back that information onto this coroutine.
Yeah, that's correct. Yes. Yeah, if you need information to keep processing, then you will have to wait until you get it.
So if we consider this case, right, so then we are acknowledging that there might be situations where some requests would take more time. Say it has to go back to the core and get some more info, right? So there could be some requests which could potentially take more time, and compared to some other requests which could then get done very quickly, right? So we have two kinds of requests. One could take time, the other could be quick. But because both of them are being read from the Kafka bus, how do we commit them? So we have to hold back the ones that are read later unless we commit the ones that have been read first, right?
I don't know with the Sarama client if it works still the same way or not, because you can commit a specific message, not necessarily an offset. I need to look at it a little bit more in details. I don't think it's an issue with the client that we're using, but I'm not 100% sure about that.
Okay, yeah, maybe we will also dig in a little deeper into this and see if we can, because as far as I could recall, I think we can commit only to the latest offset, but yeah, we can cross-check again. So, so as we were pondering about this thing, so the other design approach that came to us is that why not have only one thread or one concurrent path per OLT device, and in that case, we could avoid all of this. But that limits our scalability in terms of the number of cores that we could use to process the events for a particular device. So, so considering that, this is.
Yeah, if you have only one thread passing everything on OLT, then you'll get in this problem all the time, right? Because that one thread would be the one doing everything.
Yeah, so yeah, that would limit our scalability. Yeah, so considering that, that's why we are proposing this approach.
One question. I'm just wondering. We're talking about the containerization adapter. So this has nothing to do with the Go or not, right? So this is not what I'm saying. All the topic we're discussing here is sort of the message in between the core and the Kafka and the adapter. So I think I feel like we're kind of discussing the fundamental question here. It's a good discussion, but at the same time, doesn't matter with Go or Python. These are the topics we have to address, right?
Yeah, that's correct.
Yeah, but the current Python implementation would be with the twisted framework, which anyways is single-threaded.
Right, but the Go, I think, on the threading part, I think the Go, my understanding is Go provide multi-thread, and that's the reason why we want to go forward with that, right? So okay, no, I'm just want to make sure, you know, that the stuff we're discussing here, it's good because we're looking at the containerization now, so I think these questions are coming up, but I'm still not sure whether this is Go specific. You know, things like.
Yeah,
right?
you're correct. Yeah, you're correct, Sean. It's not Go specific because those are any languages that we use will need to address those issues.
Right, and then Ken, back to you is, you know, when you guys dealing with the PONSIM, has been addressed in the PONSIM and defined in the interface?
Oh yeah, it is. But PONSIM is a very limited implementation. Right. So we can't. It can be used to start all the containerization, but once we start to use like a real OLTs and real news, we'll have real questions, and I expect even the interface. I expect that we might need some additional API, some augmentation on that API, so some modifications, and that's perfectly normal.
Great. Okay, I guess we have another page. I mean, that's what is. I mean, we have another second option, right?
No, we have not listed out the second option.
So what's the conclusion? so help me out with that.
Yeah. So what we are saying is that this is a downside of the approach chosen, but given that we really need scalability, so because this can be handled, right? It's just a question that we need to store the context of the messages that have been processed completely but yet cannot be committed. We need to store that context in the adapter till they become eligible to be committed. So we will put in the implementation of that sort. So that's the current thought process. But anyways, as Ken was saying, we will go back and cross-check on that, and we'll come back on this.
But again, you said the stuff will be stored in the adapter or in the KV store now. What do you?
This can be stored in the adapter as a local state, because if the adapter crashes, it would reprocess all of them again from the Kafka bus.
If the adapter crashes, okay.
Yeah, so if the container somehow dies, right, where say 3 of the messages are yet to be committed, and it starts back again, it would process them again, and it would process them again basically.
Okay. We definitely need to address the failure condition. I think, you know, right now, to me, it's still kind of
it would process them again, and those requests would definitely fail at the lower layers.
Okay.
Just as minor thing about the no local state. So we've seen how KV store accessing KV store on packet processing, like for example OMCI, really affects performance. And so I think my suggestion is to have a stake in the ground saying that no KV store accesses for packet processing. Everything goes only cache local cache lookups, if possible. So I don't know. Maybe give that some thought.
Yeah, so that's the guideline we are thinking of following. That first is no local state at all, and even if we need to store something, if that can be rebuilt when the adapter comes back up again, we would follow that. And if that can't be, then as a last option, we would think of storing it in the KV store. But yes, I agree to your comment that we should avoid doing it on a per packet or whatever per request basis.
How about the high availability though? And so the backup adapter needs to build its state as well, right?
Sean, we have not really thought through high availability at this point of time. The first intention is to have it functionally working and being able to scale. But at least the design principles that we are trying to put in, we feel that this is not going to let us move towards that. It's not going to stop us move towards high availability, because as long as we minimize our intention would be to have no local state, right? If we can achieve that, then achieving high availability should be possible in a much easier way.
The difference between 1.6 and 1.x and 2.0 is that 1.x gave the adapters by default HA because they were residing co-located with the core, and so in 2.0 adapters would have to completely rethink HA, especially like losing a message coming from the OLT, for example. Things like that. We don't have load balancing on the southbound side. So anyway, that's something that I don't know whether you guys have started thinking about, or you're just keeping that for later.
Yeah, Shad, we have not really given it a good thought as to how exactly we could do that. But what we are trying to think about is at least the design that we put in should not block us from going towards the HA architecture. So we're trying to avoid things, see things that that does not hamper us in the future. So if anybody has any comments in that regard, saying that, okay, this particular aspect of the design would create a problem when we are trying to achieve HA, we would be really happy to take those comments.
Yeah, and no, not that anybody else probably has thought about it. But if we don't have a general, very high-level design for adapter high availability, then it'll be difficult to design for HA to begin with. Like, as you're saying, that you want to keep that in mind. But if we don't have even a very high-level view of how we're going to do HA, proper HA with the adapters, it'll be difficult to keep that goal in mind, when we design through. So maybe at some point we need to all get together and discuss adapter HA and just come up with a very general design, and so that we're not totally off.
Yeah, agreed. That's one thing I'm wondering. Right? So maybe the face-to-face lockdown will be in 6 weeks. I don't know whether that's something the adapter HA can be discussed during when we were in the face-to-face lockdown. So I think that's definitely one of the items I would like to be added. But at the same time, maybe in 6 weeks the work on the containerization has progressed enough. We will have the basis to talk about the adapter high availability also. I think last week I asked Sergio about whether the affinity router can be used on that level also. I think if I remember correctly, since I was very sleepy at the time, is if we use affinity routers, and the Kafka message bus interface approach will not probably appropriate for that. Maybe I'm stating wrong, but we definitely need to. Ken, is that correct?
Yeah, you stated correctly. If we use an affinity router in between, for example, the core and adapters, then obviously we are removing the Kafka, and that could be something that we may give a thought about it, because obviously we can't take the affinity router as is. It will be almost like it needs to do the work but upside down from what it's doing from northbound. But it will add, I would say it would add speed compared to Kafka. Kafka is fast, but it's always creating topics and all those things. It's slow, especially when we create topics. That's when things are slow. Other than it's fast. But if we want to be like consistent and use a routing engine across all components, maybe the affinity router would be the best. But even if we go with, suppose we say, okay, we're going to drop Kafka and go with the affinity router, there's not a lot of changes that needs to be done in the adapters or even in the core southbound, because currently what we have, if you go to the first page on the drawing that you're showing, you have this Kafka intercontainer proxy. Basically, it would be like another library that would be put there to deal with the affinity router. So anything else down there would, with some small tweak here and there, should remain as is.
I think.
Sorry.
Go ahead.
Yeah, Ken, I think, yeah, that's a very good topic, because this is something that came up as we were discussing on this design, that because we have chosen Kafka, what about the scalability? Because each of the devices are going to use a topic of their own. So potentially, as I understand, each of the ONU devices has to have a topic of its own. So how many topics can we really create in Kafka? If I have a full-blown pod, say, with 100,000 ONUs, would that mean that we have to create 100,000 topics?
Topics also don't scale that great in Kafka. I don't think it would withstand that. At least that's my reading of the documentation.
Yeah, it's Kafka is not very clear when it's come to number of topics. They always say it's unlimited number of topics that you can create, but we all know that's not true. There's a limit somewhere, and I don't know that limit. So it's that's something that. But on the other hand, like, will we really have a pod that will have 100,000 ONUs in one small pod? That's we need to also think about lateral scaling as well.
Yeah, I think.
Yeah,
go ahead.
Yeah, I would think that we could have pods where you might have 100,000 ONUs. Yes, definitely there will be a lot of instances of the cores and maybe a lot of instances of the adapters, right, Docker instances. But and we can have the Kafka in multiple replicas, but logically there's going to be one Kafka bus, right, and all the topics being created on that bus.
Yeah, even in the AT&T pod, if you have 128 way split, you get 32K ONUs.
Yeah, so I think we need to bring up the scalability on the pod from the service provider point of view again. The one question is, on the topic, right? So each ONU, if we use multiple unis, is that ONU per topic or is it uni per topic?
It's device per topic.
Device
so it's not
per
when it's device.
Okay.
And I think we also need to decide how many devices each container will handle. What will be the relationship between the containers and devices?
Yeah.
Yeah, that's
I think,
Mhm.
you know, definitely, I think the high availability maybe Ken, I just wondering, maybe you and Sergio and the team, we can start thinking about that, right? So if we can use Affinity Router and it has the good performance, then whether that will be the approach we should, pay attention on, right? And again, implementation today for Kafka, and then moved later for different. As long as I just want to make sure, it will not be too much interruption. So from in near term versus long term, right? So and then right now, VOLTHA, I think we need to focus on the long term. We have been staying on the short term for a long time, so we definitely need to look further down the road to make sure we have a solution and address the scalability issue also. I think different. Sorry, Ken, you were trying to say something?
Yeah, and that's the reason why, for example, like when we use Kafka, we put a set of libraries, like some shim layers on top of the core business logic, because if we think at one point of time that Kafka is no longer good, we can just remove those shim layers and replace them with a different shim layer. So like if we want to go to Affinity Router, then that shim layer would be gRPC. So it's that's the whole reason why we chose that kind of design, so that later on, if we have to swap something out and put something back in, why not? It shouldn't affect the entire system. It shouldn't be an entire rewrite of everything.
Okay. And for members here, if you're not aware about the shim layer discussion stuff, I think Sergio addressed that in the ONF Connect 2018. They are recording on that one in the presentation. So if you have not visited that, I would strongly suggest you to take a look at those. Okay, Amit, back to you. Are there any additional stuff you want to talk about?
Yeah, there's one more slide. Yeah, just it's pretty simple. Just showing the high level like module decomposition, right? So what we see in the light yellow color and the blue ones inside that are like logical modules and submodules. Right now it's more or less following the current Python implementation modularity. So we would have a resource manager, a flow manager, stats alarm manager, gRPC client to talk down, and we have some utilities which would more or less mimic the current implementation in the Python code, the file platform, which does the encoding, decoding of the IDs. So we plan to put that in common utilities submodule. And then there would be another module for processing the device agnostic RPC messages. And then we have the tech profile lib and the pond resource manager lib. So we will try to rewrite these libraries in GoLang, and they would be used as libraries. So just wanted to show how we are planning to structure it from a module perspective. The rest of the slides are pretty self-explanatory. It's like for people who know the current Open OLT adapter, it would be pretty easy for that. Basically, what each of those modules and submodules would be doing. So I'd skip those.
So thanks. Do you have some timeline on this, or how are you going to go about it? Are you thinking of this as a completely Radis's only effort, or are you looking for? Do you need resources, and kind of some timelines that you're looking at? I believe this is something driven from DT. So do you have any timelines to adhere to?
Just for information, the timelines that we are looking at is like by mid of March, we would get to have EAPOL up to EAPOL. So we would be trying to get the OLT activated, the ONU activated, and being able to do EAPOL, and we would stretch to achieve more than that, but we would basically we feel confident that we should be able to hit till EAPOL by mid of March.
You mean EAPOL and traffic?
Not traffic, maybe not the IP forwarding flow rules, but at least handling the EAPOL and flow rule and being able to provision that on the device till that point at least.
Okay, so and traffic would be like a month later after that. So I'm just guessing.
What I am hearing, what I'm hearing from the team is that we would try to stretch to have traffic by that time, but we're not sure about whether we can achieve that or not. But we're confident that till EAPOL we should be able to achieve by mid of March.
When you say there's no potentially the traffic will not be there.
The other dependency that we have is to really test these with the real devices. We would need the ONU adapter to be continued.
Right. That's true.
There is dependency on that, and in the intermediate, right, till we have that, we're going to do some hacks so that at least the OLT part of the things can be tested out. Maybe not with real devices, with the BBSIM. So we would do some hacks out there, but once we have the ONU adapter, that's when we can do real testing.
Yeah, unfortunately, BBSIM also requires OMCI.
Yeah.
Yeah.
Okay. Yeah, but yeah, so that's what, right? We have to hack into both the sides. So we would have to hack into BBSIM to really not interpret the OMCIs and things like that.
So why not pursue both? I don't see how you can containerize one and not the other. Right? I mean, why hack? You'll touch BBSIM also, but what's the point? Why not just containerize them both?
I mean, right now we are working on the ONU adapter, containerizing it as well. So there may be a convergence of timeline where the Python Open OLT adapter may come along, and then the Go version Open OLT adapter may come along, but then the Python ONU adapter, whichever one is available for it to work or try against first, we'll see. But
so
right now,
so Matt, when you're working on containerizing the ONU adapter, aren't you automatically also containerizing the Python Open OLT adapter?
We're working on both at the same time right now, yes.
Which is my point. You kind of have to, right, Amit? That's what I was trying to get at. But okay, but I see Matt's point, right? So if the Python ONU adapter is not being proposed to be converted to Go, then perhaps the AT&T's efforts might converge with yours, and you can use the Go-based containerized Open OLT adapter with the Python-based ONU adapter, both containerized.
Right, and we're kind of hedging our bets in terms of timing. Just the hope is that moving the Python code functionally stays the same.
Right.
It might come quicker, but again, like the conversation earlier about core messaging, if certain fundamentals have to be readdressed, then that adds time to everybody.
Yeah, of course.
Yeah, that's the same lines that we are also thinking on, right? So if we could align the timelines or where both these teams are, or of both the parts on which these teams are working, then it would help both, right? Because even to test the ONU adapter, you need the OLT adapter. Yeah, so we need to sync up on those timelines.
I would almost say that if you and if Radis is an AT&T, I'm almost proposing another brigade, but I'll leave it to you. But it might be worth it to sync up more often,
right,
and work more closely together. Just a thought.
Yeah, we've talked through email, I guess, last week or so, and we're starting to get to the point now where we're ready to start wiring up Kafka events to existing API calls. So,
Okay.
kind of some parallels there would conversating over those would be good.
We have only a couple of minutes left, so I did want to just quickly bring up this topic that it might be worth it to think at the same time while this all activity is going on, how you can flip the affinity router over to the bottom side. Maybe even work on that while this is all going on, just because those concerns of adapter HA have been brought up before, and they're not going to go away. So
yeah, for sure.
it's worth spending some time on it.
That's
If
something
that's
that
the decided path, right?
Sorry?
I know we talked about that as being an option, but I mean, do we want to explore what the options really are? That versus, I don't know, what are the other options that are available to us, as well? I know it wasn't decided, but it might be worth deciding real quick.
Yep. Agree.
I mean, well, the one thing I can think of is having multiple instances of adapters all subscribing to the same topic, but the one that's actually doing the work does something southbound, whereas the other ones basically are just keeping up with the changes. And then at any moment the other adapter takes over, it already has in its memory the state, if you will, and just starts actually sending OMCI or actually sending OLT gRPC, something like that. I mean, that's just an idea I thought of, but I don't know if we've explored all of those.
Yeah, I mean, all I was trying to say is that, 1 month later, we shouldn't come back to the same topic at the same point, right?
Correct.
That, oh, we need adapter HA, let's think about it. So I'm trying to encourage folks to think about it.
Yeah, and Julie, I like Saurabh's idea. Maybe we should have a brigade on the adapter side. So maybe we can talk about that a little bit later. Maybe we can decide. I think AT&T and the Redis, and I think I think HCL, the Arum also will be involved. Maybe some of the team we should have a separate short dip brigade we can address. And then Saurabh, I'm sending out the email to Sergio and then Ken regarding to the HA, reverse of the affinity router.
Okay.
So I've got 1 minute left before we need to drop, because I know the SIBA call starts and a number of folks, including Zach. Zach may have left already. He has to kick that meeting off. We have no topics for technical deep dives lined up for this Thursday. Do we want to continue discussion related to this topic Thursday? Are there other items people would like to bring forward? Any suggestions for how to best use the time on Thursday for the group?
I'd say let's continue. Maybe.
Sorry, this is Amit. I might not be able to join the call on Thursday.
Okay, great, thank you. So let's at least do some email back and forth, Matt, Amit, Sean, others, related to whether a brigade would be beneficial for the work going on in parallel with Python and Go tracks, so to speak, and see where we can. Was there a comment?
No, I think correct. Right.
Oh, okay. And we're out of time, so we'll work up some. Go ahead.
Just so again, the face-to-face lockdown will be in Huntsville, the week of March 25th. The meeting will be Tuesday, Wednesday, and Thursday, and I'll make the same announcement at the SIBA call right now coming up. And so I think the hotel is getting busy, so I suggest all the people start making reservation March in the face-to-face meeting again. I'll send out the notice on the VOLTHA Discuss also.
Great, thank you, Sean. We're out of time, so I'll go ahead and wrap up the meeting. Last comments before we drop today, and Amit, thank you for your presentation and to everyone for the discussion.
Thank you.
All right, I'll close the bridge. Thanks, everyone.